Demonstration of the working of reverse image search code on IBM Watson Studio. Initially, we go to this link dataplatform.cloud.ibm.com, and if we don't have an IBM Cloud account, we sign up for it. Go to this page, log in. Once we enter this page, uh, we'll never have something like this initially because none of the services are allocated. So we go to services and Watson services. Under Watson services, we'll have to allocate something like machine learning, and we once we add it, we'll get a free plan. So as you can see, my machine learning instance is active, and it's a free plan. Now going back, we get we get to create a project. So as you can see, I've already created my project. So you can click on create a project and create an empty project. So let me create an empty project first. So your cloud storage has already been allocated if there is one, or if you'll have a drop down option if there are many. So I'll create a dummy project. So now the project is created. We go to environments, and nothing has been allocated as of now, but we'll have to choose our environment. So we create a new environment definition, and we'll choose something with the highest configuration, and Python version 3.6 must be sufficient. So once we have set the environment, we can create it. The environment is created. Now we create a new notebook. We can either upload it from a file or directly get it from a URL. So what should be done is go to this GitHub link and copy the URL and paste it here. We can type notebook name. We can give a name as uh, notebook GPU accelerated. Though we don't have a GPU option here, GPU option comes with a paid plan. Though the code is well optimized for GPU, it uh, works much quicker. Now this is the notebook. It's fetching the notebook. So in the meantime, we'll have to upload our data. So um, let me open terminal and show what type of file that is. So we type in file, file name, and then we see that it is a TAR archived file, gzip compressed data. So that shows that our data will sufficiently will I mean properly open up and be read by the notebook. Otherwise, there are some HTML or other sort of um, data within the zipped file. It won't be convenient for the code. So this is the stock notebook without any changes. So this does not, uh, this is to directly fetch from the site Caltech dataset. This is to directly fetch from the site and unzip it. Since in a situation where this is not available, let me go back to my previous project and the original one, show what we can do in such a case. So suppose we have to add this data to our project, we can just drag and drop it and automatically it gets uploaded. So since I had renamed my file as such, I have already connected it in my notebook, added this file in my notebook. Now it has uploaded the data asset. Alright, so we can see that it has uploaded the data asset here. Now I go back to my notebook. So to edit any code in the notebook, we have to go to edit, click on edit, and this is a regular Jupyter notebook. So once the notebook loads up, we can edit individual cells, add multiple cells, edit our code. So to add our data file, that is the zipped file, we'll have to go to this icon, click on this icon. So we can see that there is one more object here. So to show how it is added, I'm going to create a new cell and insert it as a streaming body object. It will automatically name it as streaming body 2, though I don't want this since it is the same file. The same code has been written over here, typed automatically over here. This has been named as streaming body 1. So I made a change in this file, so you can copy and paste this code. Import tar file. This is to get it from the streaming body object within the notebook. So it is reading it, extracting it. So now I see that it has extracted itself as a 101 object categories without any extension. No more changes from here. There is one change right about here. So Over here we give the maximum number as something less than 1000 since it is not GPU accelerated, though their recommendation is to keep it less than 30, but we keep it as I kept it as 500. It may not take a long time, but it is still a considerable amount of time um, to train this thing. So there are no more changes in the notebook from here. So this is a reverse image search code, the image that I've given and the image that it has searched, the similar images it has searched for. So once it finishes running, we can go back. We can go back to the project and stop the notebook in order to prevent it from utilizing all the free compute power. So you can see that the status of this is running. So we'll have to stop this notebook. So those are the basics of running Jupyter Notebook on IBM Watson.